So welcome back. Our next speaker is Martin Krallinger. He'll be talking about NLP in health. As always, we don't tell you much about the speakers themselves, but please, click on their links and see on their web pages what they're working on and how you may want to, cooperate or at least ask them things. So, Martin, thank you very much.
Thank you. As you can realize with my voice, I have a terrible cold, so I hope I can speak for 1 hour. So I will try to provide some summary on basically health-related or clinical-related, biomedical related work in the domain of natural language processing. And obviously, you have my email here. So in case you want to follow up on some items or interested to discuss something, I'm open to interaction. So I'm Martin Krallinger. I work at the Barcelona Supercomputing Center in Spain, and I'm leading a group specialized on natural language processing, specifically focusing on health and clinical data. So basically the overview of my talk will be, or at least that's what I try if my voice keeps up with me during the hour. Basically I will provide some background and introduction. So what's special or what's like the peculiarity of clinical or medical textual data and language, and also the importance of biomedical NLP and clinical NLP. And then I will provide very quickly some general overview on what's going on in terms of the generation of medical language models. And I'm not going into a lot of details of these models. You have information on slides, so I'm not trying to promote any of these resources in particular, but for you to have a more detailed look later on. And then I will provide a more like personal perspective on how to implement or how to generate clinical and biomedical NLP tools and resources, at importance on high quality annotated data collections and human-in-the-loop data annotation strategies in health. And I also will show you a couple of applications of these technologies in biomedicine and health. Then basically I want to stress also, in part because I'm working a lot on clinical NLP shared tasks, also in collaboration with colleagues from Demokritos in the BioAsk Challenge. So I wanted to stress also some of the ongoing activities on clinical shared tasks, and maybe also to invite some of you to have a look at them and participate, in particular also beyond what's going on in English. Then I'll show you a couple of international and national projects we're working on, and try to conclude a little on some of the important take-home messages, at least from my point of view. Regarding the background or introduction, obviously health-related content is highly valuable for clinical data management and assistance of clinical decision support in healthcare settings. It is also a rapidly accumulating kind of data sitting inside the clinical at the clinical sites. So there's some estimate that basically in terms of healthcare valuable in data types, 80% is unstructured, which is mainly textual data, clinical records, clinical narratives, as well as clinical images. So these are kind of two data types which are really key to process and extract, and where natural language processing can play a critical role. Most of what is going on, if you look at medical informatics, AI in healthcare, AI medicine, most of the publications are actually working on structured data, clinical coding, lab tests, experimental outputs with a sort of structured data collections, and also somehow imaging. But still, in terms of clinical NLP applications, obviously in part due to the difficulty in accessing data privacy issues, most of this technology haven't been, let's say, integrated into the clinical daily life as such. It is also important to stress that this is like a big data scenario. If you look at, for instance, only a single region in Spain, like Galicia, which has like around less than 3 million inhabitants. There are estimates that every day they're producing more than 200 clinical notes. So there's a big potential on also data exploitation, especially by building language models, if obviously there's some connection between HPC infrastructures and clinical settings. So there's obviously always these issues on data scarcity for building some of these models. Data is there. The only issue is here that it's sitting inside clinical settings where basically this data cannot be shared outside. So basically, these kind of data collections are important for many applications, clinical decisions support, to select patients for clinical trials and stratifications, to prioritize patients also in terms of treatment options, healthcare management. So you also, what happened with COVID, so one of the main issues was that this kind of information was not really easily accessible, not structured. So it was a big challenge for the healthcare management and also the healthcare community to actually be able to explore and exploit this data more efficiently for epidemiology or for disease outbreak management. So what kind of data do we have, or what kind of data are people working on in the healthcare NLP community? So most of the people are working on using data collection, scientific literature, medical literature, and databases like PubMed or PubMed Central are one of these key resources. And then the second type of data which have been explored a little more is like clinical records. And I will come back to that later on, and also what kind of biases and issues are there in terms of clinical records or healthcare records in terms of data usage for clinical NLP. But it's important to stress also that there are other data sources which are key if you want to build NLP solutions for healthcare to provide a more comprehensive view of patient health or population health. And some of them have been explored already, like social media for disease surveillance, disease outbreak, and also for pharmacovigilance. But there are also other kind of content sources. Some of them haven't been really explored or exploited so much by the NLP communities, such as like user-generated content, basically patient-generated content, patient fora, but also other kind of informations, like the health web content beyond English as well. So most of my talk will really focus on scientific literature, medical literature, and also the usage of clinical records for clinical NLP applications. So why is it a very challenging field or application field, and why it's also, I think, interesting to work on clinical or biomedical NLP? I think most of you, if you went to the doctor and you got your medical records back, you could see that they're not really very well written. They don't have much time, so it's often very difficult even for the end user, for the patient, to understand what these records are about. So why is this kind of clinical or special domain content very difficult to process by means of NLP applications and also by some sort of supervised data extraction processes? Obviously, medical language is very complex. It has a high density of domain-specific terminologies. Then obviously there's the issue of ambiguity. So we'll see this later on. There's a high density of telegraphic expressions, abbreviations, and acronyms in clinical records. And this also, there's a dependency depending on the specialty. If you went to the ophthalmologist and read your record, it's basically just written in forms of abbreviations. So it's very difficult to actually understand and extract these kind of highly ambiguous expressions automatically by means of NLP technologies. Then obviously there are some localisms, so depending on the region, depending on the hospital, and depending on the speciality, there are different ways on expressing and encoding information in clinical data. It's very noisy. There's no doctor in here, so they can freely speak about that, but they really don't write properly. There are grammatical mistakes, syntactic mistakes, lack of punctuations and accentuations and spelling errors, incomplete sentences, sentences without verbs. So this is a very challenging kind of content, and that's why general domain NLP application usually do not work very well on clinical content. And obviously our clinical records are not all written in English. So I think one very important thing to stress, especially here in Europe, is that most of the European clinical records are actually not written in English. And most of the clinical NLP research is done with data sets from hospitals in the US. So it's very important to stress this importance on language adaptation, gross language development of clinical NLP solutions. And then there are like two things which are a little controversial. One is like this, are there out-of-the-box NLP solution for the medical domain? So there's always this claim that, general domain tools can be fine-tuned to clinical specialties and that's it. But often you need to keep in mind that you need to have quality controls and further fine-tuning these applications to the specific clinical characteristics of each site. And I think it's important to keep that in mind as well. So I told you already all the errors and the difficulties in terms of extracting information. Here's just an example case in Spanish, and I put my examples on purpose, not in English, because in our case we're working in Spanish, and I think it's also important to stress the importance of developing tools beyond English, and that examples also sometimes need to be in other languages as well. But I think you can understand the text on the upper side is a clinical text full of abbreviations, real clinical content, so they're describing a patient. Basically, it's full of abbreviations, and if you want to extract actually the clinical information, you need to do this abbreviation resolution to be able to exploit the output. Abbreviation resolution is a very neglected task, but for clinical NLP, it's a key issue for entity recognition, machine translation, for summarization, for all kinds of downstream tasks. It's a critical thing and highly understudied. So what are the barriers we have when working with a clinical NLP? And in the end, you will see like use cases, so why it's very exciting. So I'm putting in the beginning more like the issues we have. Obviously, lack of access to data. Clinical records, they are under privacy preserving scenarios that cannot be shared. So often you need to have some anonymization or more, let's say, sophisticated approaches to be able to process this data in-house. So there are not many data sets to be used for clinical NLP. Many of these data sets, they lack proper annotation schemas which are shared and guidelines, so it's difficult to actually exploit these. And then obviously there are issues more related to insufficient common conventions, standards on how this data annotation should be carried out. And there's a lack of reproducibility, which specifically in the clinical biomedical field is critical. And also limited collaboration across people working with different languages or with different type of application domains. And these are very important things which I think are resulting in some of these current limitations of clinical NLP solutions. What are the efforts which can be actually contribute to mitigate this problem? Obviously, I'm stressing the importance of shared tasks and community evaluations as a strategy to share data collections, to share also high quality manual annotated annotation schemas, and to foster a little more like the reproducibility and collaboration and scalability of different solutions. What has been done, for instance, in Spain to promote the development of healthcare NLP solutions? There is a strategic plan by the Ministry of Economy to promote the development of NLP solutions for Spanish, and we collaborated with this effort, and I think these pillars of these Spanish efforts are easily transferable also to other languages and other solutions in healthcare NLP. One obviously is to promote the access of high quality annotated datasets and datasets in general. The second part is to release open code, especially for key clinical components like entity recognition of diseases, symptoms, and medications, and other applications which I show later on. shared tasks. So we have been organizing over 15 shared tasks for clinical NLP in Spanish. And if you look at the number of papers and resources now in clinical NLP, Spanish is like the second one in terms of the output and the research in healthcare NLP, obviously after English. And then obviously the issues more related to the legal scenario, accessibility of domain-specific clinical language models, and I will come into that later on, and annotation criteria. And people have been, trying to argue and see, promote different, or propose different solutions to overcome these barriers. So still have enough voice. I think I will make it for the hour. I will only briefly mention some of the health or clinical or biomedical language models. And I think you can have more details on the slides and the follow-up publications. But it is a very active area of research. So there are many efforts ongoing related to the development of medical language models. Although it's important to stress that most of them are either multilingual or focusing content on English. So obviously there are like 3 types of approaches. One is related to pre-training from scratch. The other one is fine-tuning these models based on general domain models and then adapting them to healthcare or medical content. And then another option obviously is using prompting to generate some of these outputs. What's the aim of these of these medical language models in general is basically to reproduce or to reach human level performance or expertise, and in most of the cases they're focusing more on question answering type of evaluation scenarios when you look at the generative language models. So there's an explosion of different types of models being adapted and implemented for the medical domain. So here you can see an overview on 3 different types of approaches, more related to the number of parameters. Obviously, the family of the bird-like models, which are quite smaller than the llama-like models adapted to the healthcare biomedical domain, and obviously the latest advances or latest developments are going into PaLM-like or GPT-like medical models. So what are the main aspects of medical language models to look at? And I will try to address a couple of them later on. So obviously the first thing is actually the pipelines or the principles on generating these models. And this is not very surprising. There are mainly 3 types of approaches on generating medical language models, and not only in medical language models, but others as well. So either pre-training from scratch. So here the assumption obviously is that you have enough in-domain data to be able to build these models, and also that these models with medical domain pre-training work better than adapting general domain models or fine-tuning general domain models to the medical field. And then obviously very active areas like prompting and prompting these general LLMs. So this has to do also with the associated data, and I'm not going into details in there. I will show you a couple of relevant data sources for these 3 approaches later on. And obviously also like in other scenarios, you have more discriminative tasks, mainly focusing on entity recognition of clinical concepts, relation extraction, and association extraction, and then basically more like generative tasks, which are mainly in the clinical field related to question answering. There are quite a lot of benchmark data sets for question answering, and some also for semantic text similarity and summarization. So what are the applications which are currently being used in terms of application scenario of these medical language models? One is related in theory to medical decision making. I think this is like let's say a claim of these language models which in practice isn't being follow up very, let's say, in details because of the legal scenario to use these language models for as assistance to decision making in the clinical settings. They need to be approved by regulatory agencies, and this is very difficult actually currently in terms of the practical application scenarios. They have been used for clinical coding. So clinical coding basically means you have a clinical record and you have to determine what is the diagnosis of this patient, the primary diagnosis or the secondary diagnosis, and also like what kind of medical procedures have been used to treat this patient. This is very important for healthcare management. Clinical coding is basically the mean on the way to structure data in terms of diagnosis, the diseases, and the procedures. And it's also a critical thing, especially like in the European settings, for reimbursement of healthcare scenarios. A hospital, basically, if he asks money, like to the healthcare authorities, they have to show what are the kind of clinical codes which have been coded in the past to get like the budget for the next year. Clinical report generation, so those which have been working on clinical records, you will see that they're very repetitive, highly redundant data types. So the clinician often uses cut and paste over time, if you look at these data collections. And if they need to find something in your medical record or your past medical history, it's very challenging. It's a lengthy text, highly redundant, so it's difficult to actually extract relevant information in a short period of time. So one scenario is actually also to use these language models to generate summaries automatically, extracting key information and making it easier for the end users, meaning the healthcare professionals, to find the important information there. Medical language translation, I will go to that later on. Obviously, if I have an accident here in Greece, maybe I don't hope it's not happening, but maybe my record would be in Greek. I need to, if I want to understand it, I need to do some translation of it, or basically if I have to share my healthcare information across different countries, medical translation is key. Currently, medical language translation has improved a lot, especially with neural translation technologies and also LLMs, but it's being used more like for synthetic data generation, and we'll show a couple of examples later on. So there are many application scenarios, and there are obviously many challenges specifically for healthcare content, but also some of them are general challenges which language models also face for other application domains. Obviously, hallucination is an issue. In particular, in healthcare-related data, hallucination is critical. I mean, these kind of errors do impact health of people, so there need to be strategies to mitigate or to control hallucinations. There's a lack of evaluation benchmark metrics, especially beyond English. So many of these technologies are being used, and it's not very clear what's the performance and what are the quality of these tools, especially if you do or you look at a benchmark, like for question answering in a data set in English, you apply it in a data set, for instance, in Czech, and the performance drop is really dramatic. Then also there's a lack of domain-specific data. So if you apply these kind of strategies, for instance, to rare diseases where there's scarcity of data, there's just not enough data to do, to train or to build some of these models. So there's domain and under-resourced language scenarios as well. And obviously there are other aspects more related to the safety and ethical concerns and regulatory aspects which need to be addressed when using LLMs or these kind of technologies in healthcare. And so what are the future directions? And well, I think you will see that later on. Obviously, generation of new benchmarks through shared tasks and through open data sets. Multimodal LLMs, so there's a tendency to have vision and structured data also integrated into these multimodal LLMs. And so many other aspects to take into account. So I'm not going into details here, but basically there's an explosion of these models. Most of them are using literature and dialogues between patients and healthcare professionals, questions and data sets and electronic health records to build these systems. And here you can just have a visual overview on the data sources and the timeline of the recent developments of these models. Just like to mention that it's not only in the medical language model field, there are not only models working on images and on textual data, but there's a lot of effort also going on in the field of basically protein or molecule type of language models. So it's not only like textual data. So what are the strategies to build these models? And I'm not going to explain all of these. So you have a summary here, and then I point out a couple of these models. So obviously there's a strategy to do pre-training from scratch. And this might be more true for medical language models focusing content in English, because there's quite a lot of data out there in domain for healthcare in English. And here you have a list of some of these pre-training from scratch type of strategies of medical language models. There's obviously Biomed GPT, which is one of the latest multimodal models, which uses both image data and textual data from publications, electronic health records, and it's trying to basically solve different types of tasks related to text understanding and text summarization, clinical documentation and captioning, image classification, visual QA. There's also, I think, an interesting resource, which is Neutron. Neutron is basically a model which relies on a very large collection of over 7 million clinical notes, so from different hospitals, and so it relies on a very large collection of clinical records to do this pre-training. And it basically is a bird-like LLM with over 100 million parameters, and they also do a fine-tuning of this model using 5 different tasks. 3 of them are more like clinical tasks, and 3 are more like, let's say, management operational tasks. One is like to predict mortality in the hospital, and the other is like comorbidity index, and the third one is like related to readmission of patients. And for doing these tasks, they use retrospective data basically to generate these models, and then they have held out data set to do the validation. And there's more specialized models, also multimodal, related to specific application domains like ophthalmology, in combining vision and textual data. Following more like the GPT-3 type of architecture, there's Gatortron GPT, which also basically has 2 types of sources for generating the pre-training, a very large collection of clinical records, and then also a very large collection of general domain clinical general domain English texts. And it comes with 2 flavors, 5 billion and a 20 billion parameter scenario. And they also have then some sort of fine-tuning of these models for different tasks, like for relation extraction, drug-drug interactions, chemical disease, and for more traditional like question answering using different open benchmark data sets. What I think is interesting of Gatortron is actually that they also use this model for generating synthetic textual data, and which was assessed by human evaluators, clinicians, in terms of different parameters, readability, the clinical relevance, and whether it was written by a physician, human written text, or AI-generated text. And they generated also a very large collection of synthetic text through this model. Then there are others. I'm not going into details. CPT basically is interesting thing about that is it exploited query logs of end users. So I don't know how many of you know PubMed. PubMed is the database being used in medicine. And the authors, they work at PubMed, so they had like, would say, a competitive advantage. They were looking at the query logs of the end users, and when I checked it the last time, it was like quite a lot of years ago, but they had like, I think, over 70 million queries. I'm not sure whether it was a week or a month, but there are really a lot of queries. And so basically they were looking at different queries and aligning queries to the target documents to build like two types of models, one encoder model for the queries and another encoder model for the article representations. And basically they try to use this model for improving information retrieval in the medical application scenarios. There are too many models in my slides, so I'm really skipping over some of them. There's one based on GPT-2 as a model backbone, and it also uses this PubMed database, this database of biomedical literature, to do the pre-training, and then have to do some sort of evaluation of this model in different relation extraction and question answering benchmark data sets, as well as text classification and generation. The others, Dragon is another one. The interesting thing is that as a text corpus and a knowledge graph, as raw input data, and then there's BioLinkBird or LinkBird. I'm going back in time, so I'm going like to the more ancient ones in the end, but they were still very heavily used. So basically here they also use basically a citation link of Wikipedia and of PubMed to as a training data for implementing the LinkBird model. Well, there's Gatatron, PubMedBird. I mean, basically, don't need to say much about this. It's basically a bird-based architecture, and they're using two content sources: general domain, Wikipedia, books, and web, and also in-domain data collection related to the PubMed database. And one of the very ancient ones, but still being used, is BioBird. Basically, it also is a bird-based architecture, and it uses PubMed database and PubMed Central, which is a very large collection of full-text articles. And SciBird, same thing. The only thing in difference, basically, is that they're using Semantic Scholar as their input data collection. And ClinicalBird, also, again, is very similar. The difference here is that they're using clinical records from a data collection called Mimic. So Mimic is basically one of the few accessible clinical record databases. You need to get approval, but basically it's a large collection of clinical records from the US, and basically did adaptation of Bird using these data collections. I'm not going into Bluebird, and basically these are the pre-training types of scenarios. Obviously, there are many other models being developed, which I cannot show in my presentation. But what is more popular, and it's not very clear whether you have enough data actually for pre-training for Beyond English. And from the recent results, pre-training doesn't really look as competitive as it used to be. So one of the more, let's say, easygoing ways to achieve better performance is through fine-tuning of general LLMs for the biomedical domain. And here there are also a lot of different models. I'm not going into the details. You can look up the papers and these resources directly. And I'm pretty sure there might be someone actually in the audience which is involved in some of these models. So I'm in order to avoid being embarrassed, I'm not going into the technical details of these models. So there's WebGemini, BioMistral. For BioMistral, I think I want to highlight that it's an open source LLM, and it's trained obviously again. The fine-tuning is done on PubMed Central, this full-text article collection. What I think is interesting is that they also try to address the multilingual aspect. At least in terms of the benchmark. What they did do is to translate these question answering evaluation benchmarks also to other languages to assess the capability beyond only English. Also beyond English is Taiyi, so this has English and Chinese. And in this particular case, they also have for the fine-tuning collection of manually curated data collections in data sets, in healthcare-related data sets in English and also in Chinese. So I think it's interesting also to see this kind of approaches, and this one relies on a sprint training model on Qwen7b. There's Alpaca Care. I'm not going into details. There's Meditron, which builds on Llama 2, and also basically the adaptation using PubMed data. There's Biomed GPT. There's Clinical GPT. So you see, there are quite a lot of different tools, and it's becoming increasingly difficult actually to see which one you should use. If you are working with English, if you're not working with English, things look quite easy because there are not many resources. And obviously, there's a recent thing. There's MedPalm M, MedPalm 2, which relies on Palm. So basically, most of the current developments are more related to fine-tuning general domain models for the biomedical application scenarios. What are the data sources? You saw already many of them rely on publications and in English. I have to say that there are also publications, especially like in medicine, beyond English. So there's a very large data collections and literature database called Cielo, which integrates publications from Spanish, Portuguese, as well as English, and basically stores medical literature across Latin America, some African countries as well, and obviously Spain and Portugal. But there are also other kind of knowledge resources for medical literature in other countries and other languages, which are, I think, important to point out. Many of them use PubMed Central or different parts of PubMed Central, full text articles. Some of them also are starting to use medical practice guidelines. And I already told you about clinical records. So one of the few larger data collections of clinical records which are openly accessible is Mimic, and the other AHR-related developments are always using either in-house data collections or very small anonymized data collections of clinical records. Obviously, web, Wikipedia, and then another resource which is being used also for more like entity linking types of applications is UMLS and tools related to models which rely on UMLS, which is a metathesaurus of medical, multilingual, a very big metathesaurus of medical terminologies. So I'm running out of time, although I still have voice, but I think I need to be a little more quick. So basically, I already told you about the issues on the challenges of the usage of language models. So I'm not going into much details. What is important to stress actually is the trustworthiness of these systems, and there's an effort in the European Union to actually account for a legal framework to define in a more appropriate way trustworthiness of these systems to be used in healthcare. I also wanted to say that at the BC, at our research center, there's through this strategic plan an ongoing effort to generate language models for Spanish and also now for other European languages. We generated at the BC the first larger language model for electronic and clinical biomedical data in Spanish, and this is publicly available on Hugging Face and is heavily being used by the NLP community working on content in Spanish. So regarding the practical applications, I think already stressed a couple of these on medical decision making, clinical coding, and summarization. So I think for obviously, not surprisingly, all kinds of more general domain or other domain types of applications are being used also in healthcare and in biomedical NLP, from name entity recognition and semantic annotation of clinical content to more efficient text classification or patient classification in this case, to summarization, question answering, and data augmentation. So related to very simple experiments with data augmentation. So I already told you about the PubMed Central or full text articles in English. So there are special publication types in PubMed Central called case reports. So a case report is basically a publication about what happens to a patient. And it's a summary of basically the clinical journey of a patient. Usually it's a more interesting patient, otherwise you cannot publish it. What we can do, what we, for instance, are working on is in using generative models to reconstruct the original record of these patients. So basically use prompt engineering to reconstruct original records which have been used to write their scientific publications, following the structure and the typology of real electronic records, in this case discharge summaries. You can use also LLMs and neurotranslation strategies to generate multilingual discharge summaries or syntactic data collections based on publications, or to use this to generate to use text augmentations for particular types of entities or variables which are underrepresented in your data set. So you can see, for instance, symptoms and mention of symptoms and how to actually use generative models to enrich or to use them as data augmentation approaches, or even to inject noise through prompt engineering to assess how robust this model might be when applied to noisy text. So in this case, these are results for entity recognition systems in clinical content in Spanish. And obviously, I told you already on about the gross language potential of these systems. So what is important here is that if you work with clinical content, you need to have the end user very much in the beginning of the implementation of these systems. And the end user in this case are clinicians in most of the cases. So you need to have a sort of labeling scenario, which is a more like collaborative effort between human and machine when doing these or trying to apply these systems in real scenarios. So I'm not going into many details here because I'm actually running out of time. You have that in the slides. So there are several aspects which you need to take into account when generating high quality and manually annotated data collections in healthcare. Important thing is actually, and sometimes if you look at the clinical application scenarios, they're not really aligned to any real use case. So there's one very popular benchmark scenario on solving entry exams of medical doctors. So I'm not really sure what is the practical relevance application scenario of such kind of question answering tasks. So it's important actually to fulfill or to look at real knowledge gaps and information needs and use cases which are a little more realistic when adapting these systems. So they're very high impact to application scenarios of clinical NLP tools. One is basically, you can simplify it as the clinical use case consists in I need to find patients with a predefined collection of clinical variables. And so you have like 100 variables, which it can be like for a patient for clinical trials or finding patients with particular kinds of conditions. So you need to have a system which exhaustively extracts these kind of features automatically or classifies patients with these features. The second one is more like large-scale data structuring. Basically, if you want to fuse these data collections with structured data, image data, it's more like generating harmonized output through NLP applications. I also wanted to stress again the issue on quality and annotation guidelines and labeling data in the clinical field. To generate annotation guidelines with the clinical end users in the loop is very complex and very time consuming and very expensive. So there are very few guidelines and annotation protocols of clinical data. So we have been working a lot on releasing these guidelines, for instance, for entity recognition tasks of diseases, of pathogens, of procedures, for anonymization, and trying also to translate some of these guidelines. They're very complex, very time-consuming. Even for English, many of them are not available. If you need to understand what is the output of these systems and the quality to make these annotation protocols public is key. One effort which is also interesting is how to actually use these annotation protocols through prompt engineering to automatically label following the human criteria content, and basically circumvent that someone needs to follow this protocol through prompt engineering data annotation. Then I already told you about the importance of consistency, obviously inter-annotator agreement and quality evaluation, and integration into real predictive modeling scenarios of clinical use cases. So what we do and what many of the other people are doing is to refine these models iteratively with human-in-the-loop scenarios, with the clinician or the end users correcting these automatic outputs. So for instance, in case of finding disease mentions and extracting them automatically, use these predictive models, you pre-label the content, and following these annotation guidelines, instructions, the end user needs to correct them, and you iteratively retrain these models. We did that, for instance, during COVID with the Spanish hospitals. They're very interested in particular kinds of COVID-related symptoms. We had a base model which was applied to the clinical records, obviously with a suboptimal performance, and only with correction of these end users of around 200 records, we could increase the recall of these models in a single iteration from, for instance, you have in discharge summaries initially around 65,000 entity dimensions, and after the first iteration, it came up to 73,000 mentions, with maintaining basically the same precision. Another important aspect, and I think also when you use like LLMs, is timing. So this, for the data selection, for the applications, clinical records change over time. So if you look at COVID, these are example cases on ranking entity dimensions across time through COVID waves. You could see that some particular entities spiked up at the initial phases and then went down. So when you do data selection and also when you do benchmarking of these models, it's very important to account for the variability across time and how robust this model might work for, on different periods of the clinical data scenarios. In our case, we have implemented many models already for Spanish, so over 40. You see here a text with automatically annotated entities. So basically what you have is from unstructured clinical content to the entity recognition with these transformer-based models using pre-training of clinical Roberta. Then the second step is entity linking or entity harmonization. So what is critical for clinical NLP is that just doing the entity recognition is not solving any real need. You need to have also a very robust system for medical entity linking, and unfortunately this is a highly under-researched areas, and there are not that many tools and systems, and also data annotation is very cumbersome. So for being able to use these systems, you need very efficient entity linking tools. There are a lot of very large vocabularies as target resources for entity linking. One of them is NoMedCT, which is multilingual. So basically, this system usually work in two steps. First, they find candidate entities in a very large vocabulary, and the second step is basically usually related to re-ranking of these candidates in a second phase. So for instance, we have implemented also in the Group 1 system following the same sort of approach. There are many vocabularies and terminologies in the clinical field, very large structured, hierarchically structured lexical resources, and I think they're also key for many of these application scenarios. But there are very few benchmark scenarios for entity linking in medicine, and not only for Spanish, but for English and for all of the other languages. There are only very few benchmark data sets, and if you look at the current benchmark scenarios of language models, this is a very, let's say, neglected application field. People working on question answering, summarization, and entity recognition, but entity linking is hardly taken into account in any of these benchmarking scenarios. And the few efforts which have been going into the direction of using LLMs for entity linking, they show that there's a very big issue in terms of hallucinations. So these usually do not work very well for entity linking tasks. And for practical application scenarios, entity linking means to transform the textual data into what people consider common data, clinical data models. You need to integrate and accommodate with standards and the interoperability of clinical content. And to be able to use it for knowledge graph, knowledge discovery, and hypothesis generation as well. So I think I only have 8 minutes left, so I will rush through a couple of slides on the shared tasks. So they're very important. I want to say also they're not only important for a leaderboard of language models, they're important also for a mean for objective and independent benchmarking evaluation. So I think this is important to stress. And in our case also for promoting harmonization, interoperability of some of these resources through a common evaluation scenario, metrics, and predefined formats and standards. There have been many tasks in biomedicine in English. We have been organizing many of these tasks also for Spanish, I told you already, for indexing and classification of literature, medical literature in Spanish, for entity recognition of all kinds, medications, diseases, symptoms, professions and occupations, obviously also for data anonymization. So just like to showcase one of these challenges, we had one on species and pathogens, which are obviously very important for infectious diseases and disease outbreaks, and infectious disease monitoring and surveillance. The systems work very well, close to human annotation quality. We had another task related to locations and places in medical content. So why is this important? Obviously, we are all traveling here. So if someone has basically was traveling to another geographic area, it's important to have more sophisticated systems to be able to extract mobility of patients and patient trajectories inside hospitals, and to harmonize this also to, for instance, either vocabularies as SNOMED CT or BLUE codes, and you could actually be able to reconstruct where patients have been traveling before. From COVID, you realize that this didn't work very well currently in healthcare, so people had to call, where have you been, and where have you been traveling, and so on. Have you been to risk areas? So this kind of more systematic way on finding places automatically and harmonizing, linking them to geonames or plus codes is critical for healthcare surveillance. We also generated data collections through neurotranslation in other languages. Occupations and professions is also an important thing for healthcare NLP. Oncology, more specifically on tumor morphology. We had also some tasks and generated multilingual data collections out of that. Anonymization and the release of a data set in Spanish. I told you about social media and diseases. So what's important is to actually be able to realize that these data collections, which might be published in another language, do show a potential for instance, in Spanish, to use neurotranslation to generate silver standard data collection through annotation projection or other kind of annotation transfer strategies, and then generate with that silver standard weakly annotated data collections beyond the original language. So one of the last tasks we have been working on was more collaboration with MedQA on multimodal, multilingual scenarios in dermatology. So basically having question answering scenario with images and questions and responses in Chinese, which was the original data source, and in English and in Spanish. So I think it's important also to stress a little more these multimodal and multilingual benchmark evolution scenarios. So I will rush through a couple of slides. One is how you implement these systems. So you have the public type of models which you can train on public data collections, annotated corpora. But if you want to apply them to clinical use cases or clinical projects, you always need to take into account how to adapt these models or fine-tune these models at the clinical site. So usually it's very difficult to get access to data. The legal approval, the ethical commission approval, the anonymization process is very tedious and cumbersome. So usually the only way to implement these systems in a more straightforward ways to have a final step of fine-tuning with the data at the clinical site. So there are some approaches to use federated learning, but in practice, this isn't what we saw is working very well. I told you already about this translation, annotation, projection. So we have been working on that. We are applying this like to a couple of projects to finish. One on a multilingual scenario for 7 languages in a very large cardiology-related project where we try to extract clinical variables for cardiology in 7 languages: Spanish, English, Dutch, Czech, Italian, Romanian, and Swedish. Similar scenarios also for heart failure, but with fewer hospitals, but also clinical sites, one in Africa and one in Latin America, to extract clinical variables by these multilingual NLP components. We applied it also to occupational health and generating associations between diseases and particular certain professions. And there's some scenarios also for epidemiological vigilance. So we're collaborating with the Spanish Center of Epidemiology to help them in building a system for disease surveillance for infectious diseases, which includes obviously also COVID and influenza, or rare diseases, in this case more like rheumatic diseases or inflammatory diseases in the eye. So I'm trying to conclude in 1 minute what are my perspectives. So it's important to take into account that there's a big variability in terms of the data types and sources in healthcare. There's a variability depending on the condition, disease, the specialty, the hospital-specific characteristics of clinical records. These records or the data changes over time, so the system need to be robust or need to be adapted or need to be evaluated according all of these different criteria. One thing is obviously privacy, so you need to be very, let's say, creative in terms of building these solutions, either through data augmentation and use of synthetic data. There's obviously the strategy to do data anonymization, but to be honest, we have worked on that topic. It's still like a chicken and egg problem. So to get access, you need to anonymize, but to anonymize, if you didn't see the clinical record, it's difficult to prove that it works very well. And there are federated learning scenarios, or what we think is a little more like straightforward is like processing in situ, with the limitations of computation, which some of this computational power, which some of these clinical sites might have. You need to align these tools to clinical needs and to real use cases. So many of these NLP applications are not really targeting any critical healthcare-related issue, with validations, quality control, and assessing the impact and usability by the end users as well, not just like performance metrics as such. And very important is interoperability. So for clinical NLP, if you're not able to integrate and harmonize your data with data standards being used in healthcare, basically you're not going anywhere. So you need to make sure that you're actually compliant with the data standard structures and interoperability criteria people are using also for structured data in healthcare. And said that, I wanted to acknowledge my funding. We have national funding and European funding. Also our collaborators from BioAsk here at Demoketros, which I didn't really tell them here, so if they're here, I mean, might come back later. So we are working at BC. It's a very multidisciplinary field. We have AI engineers, NLP engineers, computational linguists, but also medical doctors, some of them only part-time, to be able to implement these tools and aligning them to real use cases. And before finishing, I guess you had that before, we are hiring, we have 2 new positions and 1 postdoc, so if you're interested, then let me know. Thank you very much.
Thank you, Martin. We can take a few questions. Any questions? Do we have mics?
Hi, thanks for the talk, and also to make you feel a bit better. I think my throat is in exactly the same state, if not worse, than yours. I have a question regarding your opinion on the direction of some research. Do you think diagnostics is something that should be, like, either complete diagnostics or an aid to diagnostics to doctors? Is something that should be explored, or is it out of reach yet? Because I am kind of starting to maybe work on projects that are in collaboration with psychiatrists, where linguistic data and language is very important for diagnostics and could be like an indication of something. So just to hear your take on it.
Yeah, so I think your question is very important, but to be honest, I think I didn't go into the detail in the clinical data. You have like what they call primary use and secondary use. Primary use is to assist the clinician to take a decision, simplifying it a lot. Secondary use is more like for research purposes, also simplifying it a lot. And for primary use, like helping in clinical decision, the issue is here that the legal framework to get the approval is very complex. So it needs to pass like these medical regulatory agencies related to medical devices. In this case, it's similar to that scenario. So it's not easy. So I think, to be honest, and if you look at the LLMs, the biomedical LLMs, also like from the big corporations, in the end, they always have like this claim, it should not be used, it needs further testing and so on. That's because basically currently the legal scenario in using these systems as a way to like helping clinical decision making has very serious legal constraints. So my take-home message would be, for research purposes, definitely yes. But for clinical decision making, obviously it needs to fulfill the regulatory, let's say, pipelines.
Okay, thank you. And just to let you know, I mean, we can discuss this later, but as far as I know, this is going to be a shared database of records across Europe in many languages. So you might know someone that is involved, or you can step into this research if you don't know about it. But I will find you later if that's something that interests you. So it's text from psychiatric patients and healthy subjects.
Any other questions? Oh, George.
So my question was, we know that LLMs are pretty good at decoding commodity text, even encoded text. You mentioned at the beginning that medical text is very commodity, it has acronyms, it has missing words. How do the LLMs fare in that respect? Are they able to decode this medical text?
They work surprisingly a lot better than what I expected. So we're trying, for instance, cross specialty adaptation or injection of noise. So in general, they are a lot better than what you would might expect. But there are a couple of very, let's say, critical things which still, are not really evaluated very well. One is obviously the abbreviation resolution, and the second part is more like for clinical NLP. I didn't go into the details, but there are key what we call like modifiers, which is negation, speculation, temporality. So like more classical entity recognition is not enough for clinical NLP, because it's not the same thing. You don't have cancer, then you have cancer. It's not the same thing. It might be compatible with neoplasia, or it is neoplasia. Or it's not the same thing. I had it 3 years ago, then I had it during my stay in the hospital. So these kind of modifiers are critical, and so the evaluation scenario and how these things would perform with complex inference and modifiers is not very clear so far.
They're not as precise yet.
I think it's more like a lack of proper annotated data and benchmarks than a technical issue. So I think it's more like, it's not very clear, and most of the things we have is also biased towards what's working well in English. And obviously, like the grammatical and linguistic issues which change a lot from one language to another, and also bias. So if you use these tools in content in Spanish, the way you write for like a female patient might be different. And many of these things related to bias, minorities, and so on in the clinical setting are critical. So I mean, these are not addressed, and we don't know how these things are affecting these kind of characteristics.
Hi, Martin. Thank you for the presentation. I wanted to basically ask your opinion in addition to what we were talking about, the modifiers. For example, medical writing is something which is kind of advised in the clinicians during their initial education period to have some sort of standard like knowledge, so that the clinical, so that the patients they come across, irrespective of their irrespective of from where they are, the writing thing doesn't cause much problem. But when we train systems on clinical records, for example, which are maybe basically linguistic variation in medical writing, how much are there evidences of like impacting the language models or medical clinical decision support systems?
Well, this question is very difficult to answer. So I'm not aware about that. Obviously, there were like more studies on like if you have like a first year intern, the way they speak to the patient, the way they write is quite different from someone which has been there for a long time. For medical question answering, this obviously has an impact, because the way, they usually in the beginning use far more technical medical jargon until they realize either they simplify, and didn't talk about text simplification tasks or layman person transformation. Obviously, there are people working on that as well, but the style changes, and then there are also variabilities depending on geographic regions. So, for instance, for Spanish, it's not, some of the things might change. If you look at Spanish in Mexico and Spanish in Spain, you might think like medical doctors speak in the same way, but it's not exactly true. And they even some of these terminologies, they're capturing language variation. So there's like a Snow Mid-City version from Argentina and from Spain, and obviously the same might be true also for like US and UK. But your question, it's difficult to answer exactly what you mean by that, but I'm not aware about that.
Okay, thank you.